Okay, so this is the third video on simultaneous equations. Make sure you've watched the first two first, or this is not going to make a lot of sense. Let's go! So obviously the idea here is the same as with linear simultaneous equations. We want to try and find the value of the variables in the question. In this case, we've got an x, we've got a y, and we want to find out what those are. The things that are different are basically that we need to use quadratic solving approaches. So we need to think about factorizing or the quadratic formula. And also, because it's a quadratic, we're going to get more answers. If you think about the quadratic formula, you get a plus and minus answer, you get two possibilities. If you think about factorizing, you get an answer from each bracket, you get two answers. So we're going to double the number of answers, and it's worth pointing out that if you don't really understand factorizing or the quadratic formula, you should probably go and look back over them now, because this is not going to make any sense without it, and I'm not going over it another time. So here's our first question. We've got y is x plus 3, we've got y is x squared plus 5x minus 2, and I mentioned on the previous video that we're basically going to approach this as a substitution sort of approach. We want to put one thing into another equation. You can, in some isolated cases, do an elimination method, but it's very rare that that will work. Substitution is normally your best bet. And the idea is we want to take like the fact that y is equal to x plus 3, and we're going to put it in place of this y in the other equation. So just like we did when we're doing linear equations by substitution, we want to put one equation into the other one with what it's equal to. So if we do that, we'll end up with x plus 3 is equal to x squared plus 5x minus 2. And what would you do from there? Well, this is a quadratic, and it's a quadratic in x. We want to make one side equal to 0 is pretty much always your first step. So we're going to need to subtract x from both sides, and we're also going to need to take away 3 from both sides. And if we end up with that, we'll have 0 on the left-hand side, we'll have an x squared and 4x minus 5. What would you do from there? Well, there are lots of ways of solving quadratics, but the one that you want to use generally is factorizing, because it's the quickest and the cheapest. Can this be factorized? Well, if this is just a single x squared, we just need to find two numbers that add to the middle and times to the end. So we want to add to 4, let's write that down again, add to 4, and we want to times to, remember the sign matters, minus 5, and the numbers that will do that would be 5 and minus 1. So yeah, we can factorize this. We'll have 0 is x plus 5 times x minus 1, and then obviously we could set each of those equal to 0, but the shortcut is that it's just going to change the sign. So we'll get that x is equal to minus 5, or x is equal to 1. So there we got two possible answers for y, for x rather. How do we find what y is? Well, we're going to use that first equation here, that y is equal to x plus 3. So if x is minus 5, then y is minus 5 plus 3 is minus 2. And if x is 1, then y is 1 plus 3, y is 4. So we end up with these two sets of equations. So yeah, key points: you need to be able to factorize, use the quadratic formula, and bear in mind you will get more than one answer. Now, just like with the previous lot, we sometimes need to rearrange before we can substitute. And you've got two choices what you could do here. We could rearrange this to x equals 4 minus y, or we could rearrange it to y equals 4 minus x. And you want to think about which one of those is going to take the least amount of work. If we want to substitute something in for x, we're going to have to put it here, and we're going to have to put it here, we're going to have to square it and times it by 3. I don't really want to do that. What I want to find is something that y is equal to, because I can just swap that straight in there. So the sensible thing to do would be to rearrange this top one to y equals 4 minus x, and then put that into the equation below. So let's do that. We'll have 4 minus x equals x squared plus 3x minus 1. And then we've got the same thing we had last time. We just need to make one side equal to 0. So we're taking away 4 and we're adding x. So we're going to end up with 0 is x squared plus 4x minus 5. It's pretty much the same equation as before, isn't it? Nice. So again, we want to have two numbers that add to 4 and that times to minus 5. And we already know that those numbers are 5 and minus 1. So we'll have naught is equal to x plus 5, x minus 1, and we'll end up with our answers being x is minus 5 and x is 1. We then need to find what y is, and we've already got a version that we can use here. We know that y is equal to 4 minus x, so we can substitute that in. If x was minus 5, then y would be equal to 4 minus minus 5 would be equal to 4 plus 5, which is 9. And if x is equal to 1, y is equal to 4 minus 1 is equal to 3. So there are our two sets of answers in that case. Now, just because we've used factorizing so far doesn't mean that's always going to be the best way or even possible to do. Here's an example where the quadratic formula might be needed. This is a dead easy substitution to make. We can have y is equal to x, so we're just going to pop that in place of the x over here. We're going to end up with x equals x squared minus 9x minus 3. As always, we want to make one side equal to 0 before we do anything, so let's do that. We'll have 0 equals x squared minus 10x minus 3. And then if we think about factorizing this, we want two numbers that add to the middle, so we want to add to minus 10, and we want to times to minus 3. And there aren't any whole numbers that make that work, certainly, because the only thing that times is to minus 3 would be 3 and 1, or minus 3 and 1, and that's not going to get me to add to minus 10. So I'm going to have to use the quadratic formula. Remember the quadratic formula, we want to use minus b plus or minus the square root of b squared minus 4ac all over 2a. Don't wear it out. Now in this case, a, remember, is the number of x squared, so a is equal to 1. B is equal to the number of x's, so b is equal to minus 10, that's from here. And c is the number at the end, so c is minus 3, and we're going to sub that into the formula. So let's do that. So if we do that, we'll end up with x is equal to minus b, so that's going to change the sign from minus 10 to 10, plus minus square root of, so b squared, it's minus 10. Remember, if you're squaring a minus number, you need to put it in a bracket, or you need to remember that it's going to give you a positive result, minus 4 times a times c, so 4 times 1 times minus 3, all over 2a, so 2 times 1 on the bottom. And let's do some tidying up here. So it'd probably be worth figuring out this. Minus 10 squared is 100. Minus 4 times 1 times minus 3 is plus 12. So that's 112 inside that square root. So we'll have x is 10 plus or minus the square root of 112 over 2. And then we have to go to our trusty calculator. And we should get that one possible answer is that x is 10.29. And the other possible answer is that x equals minus 0.29. Cool. We're still not quite done because we need to find the value of y as well, but fortunately we've got a very simple equation to use here, that y equals x. So the y values are going to be the same as the x values. So if x is 10.29, y is 10.29, and if x is minus 0.29, y is minus 0.29 as well. So there's our sets of equations for that one. It's worth bearing in mind that you can sometimes tell an equation is going to be a quadratic formula question if it says that you need to round to decimal places or significant figures. That's normally the tip you need. Okay, here's the last thing that we could be asked to do. And this is quite tricky. So we're going to do a couple of examples that look like this. It's a case where you can't just substitute something straight into an equation. You kind of have to square it first. So in this example, I've got 2x plus y is 5. I've got 2x squared plus y squared is 11. And I think the obvious thing to do is to rearrange this top one to be y equals 5 minus 2x. But this isn't y, this is y squared, so I'm going to need to square this before I can actually find anything. Now, if you are squaring 5 minus 2x, you don't just square the 5 and square the 2x, you have to square the whole thing, which means multiplying it by itself. Remember, that's what squared means. It means times by itself. So if we want to square 5 minus 2x, we need to times 5 minus 2x by 5 minus 2x. So do a fairly standard claw with this. We'll end up with the fact that y squared is equal to 5 5s are 25, 5 times minus 2x times 5, and 2x minus 2x times minus 2x will be positive 4x squared. And we could simplify this by bringing the center together and say we've got overall, there we go, 25 minus 20x plus 4x squared. And that is what's going to go in place of the y squared over here. Okay, so let's give ourselves a little bit of room here. We have 2x squared, that's not changing, plus y squared, so plus this 25 minus 20x plus 4x squared, and that's all equal to 11. So we've taken this equation here and we've substituted in the thing we found out that y squared was. Now what should we do with this? We should definitely make one side equal to 0. In fact, even before that, we could probably simplify it. We can put the 2x squared and the 4x squared together to give us 6x squared. And do some rearranging to put it in the normal order that we see, where we've got x squared, x's and zeros. And that's equal to 11. And then we could take away the 11. And we could say that we have got 6x squared minus 20x plus 14 is equal to 0. Now if you're trying to solve that, this might be factorizable. Remember, you can always divide everything by a number and it might make it easier. So let's try that. So we can make this 3x squared minus 10x plus 7 is equal to 0. And we might want to use MAM with this. Again, you might need to look back if you don't remember that, but that's where we say, okay, we want to multiply to the two end numbers. So we want to multiply to 3 times 7 in this case, which is 21. And we want to add to the middle number. That's the A in the center there. So we want to add to minus 10. Are there any numbers that do that? Yep, minus 3 and minus 7. But this is where you can't just go into like x minus 3, x minus 7. You have to split the middle. This is like the longer approach that we use when the number at the front isn't x squared. So we'll have 3x squared minus 3x. We're splitting up this minus 10 into the minus 3 and minus 7 that we just found. Minus 7x plus 7 is 0. So we have a split, and then we factorize each half. And that's we can take a 3x out of the first two terms. And we can take 7 out of the next two terms, and that would be an x minus 1. You know you've got it right because you've got x minus 1 on both of them. And then our last sort of step here is to combine these all together, which would give us 3x minus 7 times x minus 1 is equal to 0. Now, what is x equal to? Well, 3x minus 7 could be 0, or x minus 1 could be 0. This will give us x minus 1, and the other one will give us x equals 7/3. We still need to find the value of y, however. Now, y is equal to 5 minus 2x. So let's see, let's go over here, I suppose. So this was the first thing we did. This was the second thing we did. Now let's go to the third thing we're going to do, which is using the fact that y equals 5 minus 2x. So we've either got x equals 1, and in that case y would equal 5 minus 2, so it would equal 3. Or we've got x equals 7/3, and y is equal to 5 minus 2 lots of 7/3, which I am going to type in. Which actually gives us a rather nice answer of y equals 1/3. Cool. So there's our two answers. X is 1 and y is 3, and x is 7/3 and y is 1/3. Okay, so here's another of that sort of question. I think it's probably a good idea at this stage to try and start it yourself, see how far you get, and unpause when you want me to start talking through it. You can use the quadratic formula for this one. You can factorize it as well. I'll leave it up to you how you want to approach it. I'm going to do it with a quadratic formula. Okay, so let's get started. First thing I want to do is rearrange this top equation to y equals 7 minus 2x. I'm going to be substituting something in for this y squared down here. So to do that, I need to multiply 7 minus 2x by 7 minus 2x. I'm not going to write down the full expansion here, but you should end up with, once you've collected and simplified your terms, 49 minus 28x plus 4x squared. So we're going to take that 49 minus 28x plus 4x squared, and we're going to swap it in for this minus y squared. Now, the minus y squared can throw people off, so sometimes it's an idea to work out what that is first before you substitute it in. So we could just change the signs, really. So minus y squared would be minus 49 plus 28x minus 4x squared. So that's what's actually going to get swapped in there. So this setup is going in here. Okay, so that's step 1. Let's go to step 2, actually doing the substitution. So we'll end up with x squared minus y squared. So x squared minus 49 plus 28x, and then minus 4x squared, and that's all equal to 8. We then want to try and simplify and collect our terms together. So we should end up with minus 3x squared plus 28x minus 49 is 8. And let's actually move that 8 across, I think. So we're going to take away 8 from both sides because we do need one side equal to 0 if we're dealing with a quadratic. And there we go. Now we could use this with a minus x squared, but I tend to prefer quadratics with a positive x squared. It makes them easier to factorize, certainly, and even the quadratic formula irons out a few bugs. So let's just change all of the signs there. We're essentially multiplying both sides by minus 1, so it's completely legit. And here's our quadratic that we want to solve. Now I said I was going to use the quadratic formula with this, and I am. That would be where a is equal to 3, b is equal to minus 28, and c is equal to 57. So I'm just going to skip ahead a little bit with that. So we'll end up with that as our initial debris, and we'll get that the bit in the square root is 100, which is nice because that does square root. So we'll have x is 28 plus or minus the square root of 100 all over 6, 28 plus or minus 10 over 6, and then if we add the 10 we'll end up with 38 over 6, and if we take away the 10 we'll end up with 18 over 6. Now those simplify, so we could actually write 19 over 3 for that first one, or just 3 for the second one. So there's our two values of x. Now for step 3 we obviously need to substitute that in, and we're going to use y equals 7 minus 2x because we had that to start with. So we're going to say that y is, if x is 19 over 3, y is equal to 7 minus 2 lots of 19 over 3. Which is going to give us minus 17 thirds. And if x is equal to 3, then y is equal to just 7 minus 2 lots of 7 minus 6, isn't it? So y is equal to 1. You can actually check if those answers work, of course. The 3 and the 1 is easy to check. 2 lots of 3 plus 1 is 7. 3 squared minus 1 squared is 8. I'll leave the other one as an exercise. Something that's useful to do at the end of these complicated questions is make sure the examiner is really sure which pair of answers you're saying goes together, so they don't have to read through all of your working and figure it out. So I like to put that final boxed answer at the end. Okay, so here's a couple of questions for you to try out yourself using everything that we put together so far. Unpause the video when you want to check the answers. I'll do them one at a time, but I'm not going to be talking through them in quite so much detail. Something that's interesting for the first one is you kind of just substitute it in as a bracket. You obviously don't need to square it, but we are going to need to expand that bracket. But then from there, it's a fairly straightforward factorizing. We've just got a single y squared, and we should get that y is 5 and 2, and that x is 2 and 5. You might have done it the other way around, in which case you get the x values first, but you should end up with the same pairs of answers. Okay, on to the second one. So the second one is one where you have to rearrange it to x equals, square it, and then substitute it into the top equation. And eventually you run into this deceptive looking equation. Remember, in this case, if you can take a factor out of y of everything, that you should. So we'll end up with y lots of y minus 1 is 0, and that will give us the possible answers y is 0 or y is 1. If there's not a number at the end, it's as simple as that. And then obviously we've got our fact that x equals 1 minus 2y. So applying that to the values of y that we've got, we'd get that x is 1, that's 1 minus 0, or x is minus 1. And there are our two pairs of answers. So yeah, hopefully you did get those. I've got one last example to show you, but that's the basic idea. Grade 8, grade 9, quadratic simultaneous equations, putting everything together from this chapter. So here's our application. We've got a rectangle, we've got a perimeter, an area, and we want to find the lengths of its sides. Now we could do this by a long process of trial and error, but we're going to try and use what we've learned today. I think the first thing whenever a shape is mentioned is you should probably draw it out. And we'll call the length L and the width H, I guess. W, I guess. So perimeter is 26. Now perimeter is all of these sides added together. So that first sentence would become 2L plus 2W is equal to 26. You can actually make it easier though and just divide everything by 2, because why not? So L plus W is 13. For the second one, we've got an area is 28. Now how do you find area? You times the two sides together. So LW equals 28. So we've got our first equation here and our second equation here, and we're going to substitute one into the other. Now what are we going to substitute in? Well, we can rearrange that first equation to be, for example, L equals 13 minus W. And we can take that and we can place it where the L is in the other equation. So let's do that. We'll have 13 minus W times W is equal to 28. We then just expand that out. So that's 13W minus W squared is 28. And then I'm going to move everything across to the right hand side, so I have a nice positive W squared. So I have 0 is W squared minus 13W plus 28. This stage we get a bit annoyed because that doesn't factorize nicely. There's nothing that really times is to 28 apart from 7 and 4, 14 and 2. None of those are going to get us to 13. So it's a quadratic formula deal, and we could also tell that because the question says give your answer to 2 decimal places. So let's apply our quadratic formula. We would have that A is equal to 1, that B is equal to minus 13, and that C is equal to 28, because that's what we've got. So we'd have that W is equal to 13 plus or minus the square root of minus 13 squared minus 4 times 1 times 28 all over 2 times 1. And so working out what that square root is gives us 57. W is 13 plus or minus the square root of 57 over 2. But we want this to 2 decimal places, so we're going to type that into our calculator, and we're going to get 10.27 and 2.73. However, we also want the lengths, so we should use the equation we worked out way back when, that L is 13 minus W. Substitute that in there, take these away from 13, and we'll get 2.73 or 10.27. That should be what we expect, because basically the two rectangles that will work for this will be the one where the 2.73 is the base, or sometimes it's the height, and obviously the other side just swaps over as well. So we should have our sort of final answer here. The side lengths are 2.73 centimeters and 10.27 centimeters. There we go, a little shape application of it there. Cheers.